Hello there, children. Today we are going to work with absolute value functions. This educational experience is brought to you by your Viceroy of Values, Mr. Faust. So let us begin. So first we need to look at what an absolute value function looks like in a graph. So we're going to create this with a T-chart. Now we will learn other ways to graph this simpler and more effective, but for now we're going to create a T-chart here. So I'm going to pick some points for my T-chart. Namely speaking, I pick 5 of them. I'm going to pick 2 negatives, 2 positives, and picking 0. So I go -2, -1, 0, 1, 2. Does it matter what points you pick? No. Right, imaginary voice. It doesn't matter what points you pick. However, you really need to remember that you could pick like 10,000, 20,000, or whatever, but let's keep it simple. So let's put -2 in here. Absolute value of -2, 2. Absolute value of -1, 1. Absolute value of 0, 0. Absolute value of 1, 1. And absolute value of 2 is 2. So let's plot these points. So when I get x being -2, I get y being 2. When I get x being -1, I get y to be 1. 0 is 0, then 1, 1, and 2, 2. Now, what shape does this make? A V. Very good. It makes a V. So absolute values, will they always make a V? Absolutely. The absolute value function will always make a V. So you need to be aware of that. Now, this point down here, the very tip of my absolute value, we call the vertex. What is the vertex here? 0, 0. So that is the basic shape of an absolute value. It always must make a V. So let's move on and let's shift this function around a little bit. So let's look at another graph here. So we're going to do absolute value of x plus 2. I wonder what that 2 does to my graph. So again, I'm going to pick a T-chart. I'm going to create the same points like I did. And then I plug them into the function. Put -2 in here. What's the absolute value of -2? 2. 2 plus that 2, a 4. What's the absolute value of -1? 1. 1 plus 2, 3. Absolute value of 0 is 0. What's 0 plus 2? 2. Now, 1 plus 2 is 3, and 2 plus 2 is 4. So let's graph this and see what it looks like. As I plot these points, plotting my XY coordinates, I see there that my graph has moved from what it used to be. I still have that V shape, as I always will with absolute values. So the question is, what is this 2 doing to my graph? It looks to be what we call a vertical shift, meaning moving my function up 2 on the y-axis. Do you think that always is going to hold true? We'll find out. What is my vertex here? Well, my vertex, remember, is the tip of my absolute value. That point right there is 0, 2. So it looks like when I went up 2, I simply changed the point of my vertex on the y-coordinate. Let's move on and graph some more of these. Alright, so let us look at this. The absolute value of x plus 1. I wonder what that plus 1 does in my graph. So, I'm again going to create my T-chart. Now, again, we are going to talk about here where this is how I'm going to start off showing you this. The T-chart is not the easiest way to do this. We will learn a more efficient way in a second here. So, when I put -2 in here, -2 plus 1, -1. Absolute value of -1 is 1, the loneliest number. -1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. And 2 plus 1 is 3. So I plot these XY coordinates again. So at -2, I get 1. At -1, I get 0. At 0, I get 1. At x equals 1, I get y equals 2. And x equals 2, I get y equals 3. Now, I know what you're saying. It makes a check mark. But remember, since these lines are in fact infinite, it will carry on and make that V. So, the question is, what is my vertex now? Well, I find the tip of my absolute value, and my vertex is at -1, 0. Now remember, what did this +1 do to my graph? It shifted the function horizontally, but instead of adding 1, it subtracted 1, which if you think about it, kind of makes a little bit of sense. Because my old absolute value, if I put in 2, I would get 2. Here, to achieve that y value of 2, I only have to put in 1, or 1 value to the left. Think of it like if you order a burrito. If your burrito costs you $5, but now someone is handing you $1, how much is your burrito really going to cost you? You personally, $4, or 1 unit to the left of what it normally does. Conversely, if this were subtraction, it would do the opposite, but we will get to that. Moving on. So, now, oh please, if you would, graph this following item. I wonder what the negative does. Shocked face. Let's go ahead and use my T-chart again. Now again, the world is your oyster, and as the kids say, you do you. However, I'm going to keep it simple here. So I put -2 in. What's the absolute value of -2? It's 2. But then I apply the negative, which makes it -2. Remember, the negative is not affected by my absolute value. Put in -1. What happens? Make it positive, but then it becomes negative. 0 is 0. Put in 1. Absolute value of 1 is 1, but then you make a negative. And you put in 2. Absolute value of 2 is 2, but then you make a negative. So as I plot these points here, what exactly does my graph, or what happened to it? What happened to this graph? Well, golly gee willikers, look at that. It looks like it flipped my graph upside down, which it did. Did it change my vertex at all? The answer is no. The tip of my absolute value didn't move. It simply just flipped upside down. So, now we're going to go over some general rules for all of these things so we can graph them more efficiently. Okay, so let's go over some of these rules now. I'll give you a second to copy these down, then I'll explain them. So let's talk here. The graph of y equals a times the quantity, the absolute value, x minus h plus k, has the following characteristics. This is a general function, meaning I could have that, treat that as my slope, and these two coefficients here moving my graph around. So, the graph has the vertex of hk, meaning if you have this k value here, the outside number, like we talked about with the first example problem, this number here is the y coordinate of your vertex. Always, 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 always. This coordinate here, the opposite of that becomes my x coordinate, which if you think about it makes sense, because if we go back to our example problem earlier, where we had the +1, what happened to my vertex there? It was -1. So, the graph is V-shaped. It opens up if a is greater than 0, and down if a is less than 0, which is the fancy way of saying if you have a positive coefficient out in front, it opens up, and if a negative coefficient opens down. Easy way to think of this, a positive thing, a positive, makes you smile. A negative thing makes you frown. The graph is wider than the graph of y equals absolute value of x if the absolute value of a is less than 1. It's called a shrink. Meaning, if you have a fraction in front here, think of our slope that we used to have. Our slope of our line would be less steep. It would be shrunk down towards the x-axis. The graph is narrower in the graph of y equals x if the absolute value of a is greater than 1. Meaning, if you have a positive number, like a 3 out in front, your absolute value is going to be skinnier, stretched up. Like you reach your arms to the sky, they're going to stretch upward and your arms are going to get closer and closer together. That's how that works. Now, those are not the only notes you are going to get. Let's look at some examples from me. Okay, so here are some notes from me, Mr. Faust. That's the guy talking to you. So if we have this general function here you go. K is a vertical shift. You do whatever it says, meaning if this number outside here, if you add something, you're going to take your graph and move it up that many units. Minus, you're going to go down that many units. So you can adjust your vertex that way. If this were plus 7, your vertex goes up 7. If this were minus 29, down 29! Very good, imaginary voice. Now, the H here. H is a horizontal shift. You do the opposite of it like we talked about. So a plus, you're actually going to go to the left. A minus, you're going to go to the right. Think of that burrito example. That makes a little bit of sense. If you owe someone $7, before you can buy your $5 burrito, you must pay them the $7 and then get your values. So that means you would have to put in a 12 to achieve the same value that you could have if you didn't owe somebody money. And absolute value always makes a V shape. It has to. It's not a line, it's a V. Might be a skinny V, might be a wider V, whatever, but it's a V. V. Don't forget that. So, let's look at an example problem here. So, I have the absolute value of x plus 4. What should this graph be doing? Well, since it's plus on the inside, I know it's going to be a left or a right transformation because it's horizontal on the inside. And since the rule is opposite on the inside, and you will hear that throughout this course, I'm not going to be adding 4, but I'll be going to the left 4 units. Now, here is where that method is superior. So my vertex should be negative 4, 0. And I can clearly see that it is over here, negative 4, 0. But if I did a T-chart over here, and I use these particular values, like I usually do, negative 2, negative 1, 0, 1, and 2, I get y values of 2, 3, 4, 5, and 6. Here's the problem with that. That's not going to make a V. So either I pick other values like negative 5, which I would put negative 5 in and get 1, and then I have to pick negative 4 and get 0. I would have to pick other values to find out where this thing is going to eventually hit its vertex and turn around again. You see, this is more time consuming. So what you want to do is you want to go through and figure out what the function is doing based on transformations. Let's do another example of this. So let's go through this problem here. So I'm not even going to do a T-chart here. So let's just think about what these transformations are going to do. So, first off, this 3. What is this 3 going to do to my graph? Well, it's on the outside, which means it's a vertical transformation, which means it's going up or down. Whatever this is, it's going to do. So it's a plus 3. That means my vertex is going to go up 3. Now, this inside value there of negative 2. Remember, what is it? Opposite on the inside, which means actually for this, I'm going to go to the right 2 units. So, my old vertex used to be 0, 0. That's what I had as a vertex. Okay. So my old vertex was 0, 0. Well, now, I go from 0, 0, and I go up 3 to the right 2 units, and plot that point. So my new vertex is going to be this. It's going to be 2, 3. Now, how do I get to my other points from that vertex? Well, what's my slope out in front here? But Mr. Faust! Yeah, imaginary voice. There's no number there. Guess what? There's a 1 here. There's always that ghost or imaginary 1. So that means my slope is 1, which means as I go up into the right one or down to the right one. There I go. That, children, is much superior than using a T-chart. You can do that quickly and efficiently. That was me taking my time, and it's still faster than me picking points on a T-chart. So now you have all the knowledge you need. Go henceforth and do.